Okay, let's do another example here. Let's have two inclined planes. So we have one inclined plane like this. We have another inclined plane like that. So on the left over here, let's say this is inclined 61 degrees. So I'll call that theta 1. On the right over here, this is theta 2. And so let's say that theta 2 is 33 degrees. And then I have two masses. M1, got a pulley, and got M2. And so let's say that M1 is going to be 1.74 kilograms. And let's say that M2 is 2.05 kilograms. And so now what I'm going to do is I'm going to say, let's let this thing go, and it's going to move. And I want to know the acceleration of this. And so we have two options. It could move to the right, or it could move to the left. And so this determines the sign of the motion. And so it's like, well, how do we want to do this? Well, you have a choice. You can pick to the right or to the left. So I'm going to draw an x-axis. I'm making an x-axis like this and say that way is positive. You know, just to pick a direction. Okay, you could pick the other direction if you wanted, but I say that way is positive. So that means we're ready to draw free body diagrams. So free body diagram for mass 1, we got mg pulling down. We have normal 1. We got tension pulling like that. Free body diagram for M2. Okay, we got M2G down. So there's M1G over here on the left. We got tension pulling back that way. We have normal 2. Now I'm going to say that direction is my positive acceleration. This direction is positive acceleration. Okay, so on the left, this component right here of the weight balances the normal. On the right, this component of the weight balances the normal. So we don't have to worry about them. So on the left over here, the tension is in the direction that I say is positive, minus M1G sine theta 1 is the negative direction. That's equal to M1A. Okay. On the right, M2G sine theta 2 is in the positive direction, tension's in the negative direction, and that's equal to M2A. I'm going to do the same trick I did before. I'm going to add my two equations together. So M1A plus M2A is going to equal T minus M1G sine theta 1 plus M2G sine theta 2 minus T. Tensions cancel. Okay, I do a little bit of algebra here. I find that A is equal to M2 sine theta 2 minus M1 sine theta 1 times G divided by M1 plus M2. Okay, so that's a couple steps of algebra in there, get you that. I plug in the numbers that I had. Okay, if I plug in the numbers for this whole thing, okay, so M2 2.05 kilograms sine 33 degrees minus 1.74 kilograms sine 62 degrees times 9.81 meter per second squared, divide by 2.05 kilograms plus 1.74 kilograms. I guess it should be the other way around. But anyway, you plug in all the numbers, and the acceleration is a negative 0.97 meter per second squared. So what does that mean? It means I said these masses here, I said that direction is positive, so negative meant it went the other way. Okay, now if I had picked the other direction as positive, then it would have gone that way. So the thing here is that it doesn't matter which way you say is positive, you can still solve the problem. So if you guessed it went to the right, which is where the heavier mass was, then you would have guessed wrong and would have got a negative number. I intentionally did that so that I got a negative number up here to indicate that it really went to the left towards the lighter mass because it's steeper on that side. And so that's the advantage of doing this, is that it doesn't really matter how you choose. Just be consistent and understand, well, I chose this way, so a positive number means it goes in that direction. A negative number means it goes in the other direction. When you report it, it would be best to say that it goes 0.97 meter per second squared towards the mass on the left. And that way it becomes obvious, clear, unequivocal that you know exactly what's going on. Always in science and engineering, it's better to give a little bit of extra information than to be missing a little bit of information. Even if you state the obvious, that's better than not stating it and have someone miss it. What's obvious to one person is not always obvious to somebody else.